Hey guys, we're going to be doing section 9.3 rotations today. We've already talked about translations and reflections, and this is our third transformation for the chapter that we're going to be talking about, which is rotations. So let's talk what exactly is rotation. Most of you guys think of is, we're rotating something, hence the term rotation. But what you need to know is there's a fixed point. There's somewhere that you have a point and it's going to rotate around the point, or it's a turn, I guess you can think of. And that's called the center of rotation. Whatever that point is in the center, you're rotating an object around. Typically, we rotate things in this class just mainly at 90 degrees, 270, I skipped 180, and then 360 on a graph when we talk about the rules, but then we'll get into other figures that have other types of degrees of rotation, okay? Also, what we need you guys to know is that when you are given a question, okay, and it doesn't tell you, well, first off, there's two ways to rotate a figure. It's either clockwise, okay, so if you picture the clock, it's rotating that direction, or counterclockwise, which is in the opposite direction. But sometimes in the problem, it does not tell you which direction, which you have to absolutely know, memorize, because you'll get the wrong answer, that if it doesn't tell you, you always have to go counterclockwise in that direction. So there are some rules that we want you guys and need you guys to memorize. So here are the clockwise rules that state if you start with the point AB and we're going to rotate it clockwise 90 degrees, this is where it ends up. So what I would like you guys to do is just go ahead and pause and fill in all the rules, and then we'll put some numbers to these rules. All right, so here's the example. Let's take the point to -3 and rotate it 90, 180, and 270 clockwise. So if you just think about it here, the point A and B is going to be 2, -3, so that's going to go, if you notice, B, okay, gets flipped, but the signs stay the same, so we're going to end up at -3. And then A ends up flipping the sign here, so we go 2, so that will be -2. So -3, -2 will be a 90-degree rotation. For 180, if you notice, A and B, they stay in the same spots, but they just have a different sign. So 2 will end up being at -2, and 3 will be 3. So that's a 180-degree rotation clockwise. And lastly, for a 270, if you notice, B gets switched and the sign gets switched, so 3, and then A, it does switch, but we keep the same positive negative sign. Okay, so 3, 2. So those are the rules for a clockwise rotation. Here are the rules for a counterclockwise rotation.
So notice that for this one, 180 degrees is the same rule, but that's just because 180 degrees is exactly opposite no matter which way you go on the coordinate plane. Go ahead and write these down and then try on your own filling in the ordered pairs that would become after the rotation using the point -4, 6. Okay, so -4, 6 for 90 degrees is going to become, well, B becomes first and switches places, so this is going to become -6 and then -4. The next one, A, B, is going to become -A, -B, which will become 4, -6. And then this one, 270 degrees counterclockwise, we're going to end up with 6 and then +4. So hopefully we came up with the same answers. All right, let's talk about angles of rotation. If we're given an image like this, and keep in mind this image has to be what we call regular in order to do this. And regular just means that it's got the same amount of degrees in each angle here, and each of these is congruent. Okay? So we need that to be a staple, we need that to be true in order to figure out the angles of rotation in this figure. We're going to let our center of rotation be smack dab in the middle. And so we've got to figure out how many pieces of pie or how many sections does this get broken down into. We've got 1, 2, 3, 4, 5, 6. To figure out what each one is, we're going to do 360 degrees, which is the whole way around, and divide that by 6. So 360 degrees divided by 6 is 60 degrees. Okay, So this is 60 degrees, this is 60 degrees, 60 degrees, all the way around is 60 degrees. All right, so knowing that information, let's look at the next questions. Question 1, we want to know where does A end up after a 300-degree rotation? And it doesn't say which direction, so remember we're going to go counterclockwise. Okay? So counterclockwise means I'm going to go towards F to begin with. 300 degrees is going to be 60, 120, 180. 180 and 60 is 240. And then we get to point B after 300 degrees. So my answer here is B. Okay, so where does FE? And we're talking about the segment FE in that order, starting at F and going to E. Okay, where does that end up after a 120-degree rotation? And again, we're going to go counterclockwise. I'm going to start with F. F is going to go 120 degrees, so 60 to E, 120 to D. So this is my beginning of my next segment. I'm going to write that down. E is going to go 60 degrees to get to D, and then 60 more, 120 to get to C. So this is where my new segment is. C comes second, and make sure you put that notation up there. All right, so try this one on your own. Where do you think D ends up after a 180-degree rotation? Okay, did you go counterclockwise or did you go clockwise? Well, D, if I go counterclockwise, 180 degrees, ends up at A. Okay, where does it end up if I go clockwise? Same place. So for 180 degrees, it doesn't really matter, but you've got to pay attention for the rest of those.
All right, so the last one on the back of your notes, it has a different shape. So what we would like you guys to do right now is pause it and figure out what is the degree from the center of rotation, and then go ahead and figure out how far does Z travel to get to X. Okay, a little bit different wording there for the same problem. All right, hopefully you have discovered that it is 72 degrees between each, for each angle, because you do 360 divided by 5 now, and you'll get 72. So now starting at Z, and remember we still have to go counterclockwise because it doesn't tell you, but when it says how far, it keeps traveling. You got to go all the way to X, and that's 216 degrees of rotation. All right, so that concludes our rotation, and we just ended. Mrs. Hurst might have talked about M.C. Escher throughout your class periods, or if you've never heard of M.C. Escher, he's a famous artist, and this is one of his designs where there's all these rotations within his artwork, so it's pretty cool. All right, see you guys back in class.